Okay, good afternoon. This is a brief discussion, less than 10 minutes, on how to write shorthand electron configuration notation using elements on the periodic table to help us understand where the electrons in an element are in terms of relation to their noble gases. So, just in case you're not aware, the noble gases are all of your group 18 elements. So I've got a periodic table here, so I'm just going to show this to you. So here's your group 18 elements. Group 18 elements are elements helium, neon, argon, krypton, xenon, and radon. Every element on the periodic table wants to be like these noble gases, these main 6 elements, in order to have a stable electron arrangement. So if you look on the periodic table, if you were to look and you were to actually write the noble gas arrangement, all of them have a stable amount of electrons in their orbital diagram. And you can see here the helium noble gas, the element helium, has a stable amount of s electrons, 1s electrons. It has a completely filled 1s orbital. And then neon has the 2s and the 2p completely filled. So you can see every element on the periodic table wants to be like the noble gases because they're happy. They have the right amount of electrons. They don't want to add. They don't want to take any away. So how do we write elements in their electron configuration in relation to noble gases? So the first thing we need to do is we actually need to write out their electron configuration. Okay, so here's an example of that. If we were to look at the element fluorine. So let's pull up the element fluorine here real quick. Okay, sorry, I said fluorine, but we're actually going to be looking at potassium. So potassium has, as element K on the periodic table, potassium has the electron arrangement. The orbital diagram is written here for you. I've actually written that out. It has argon as its nearest noble gas, and then it fills up then the 4s sublevel after it fills up the 4s, after it fills up the argon electron configuration. So the actual rules for this, in order to write things in shorthand notation, is written for you here. So shorthand notation is writing the electron configuration for an element using the closest previous noble gas. So once again, I said fluorine before, and here's an example of fluorine for you written on the bottom of the slide. If you want to go ahead and write this down, put it in your notes, that way you have it in the future. This is how we write shorthand notation. So go ahead and push pause on this video and write this down, and then I'm going to go ahead and move forward. So I gave an example of the element potassium. If we look again, we can write things in shorthand notation, for instance, selenium. And we know that selenium has the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. Now we write the element in brackets that's the closest nearest, or the closest previous noble gas, and in this case that's argon, which is a group 18 element. Then we write everything after the noble gas. So 4s2, 3d10, 4p4. That is the electron configuration, the shorthand electron configuration notation for selenium. We can continue doing this for any other element on the periodic table. So let's go back again and let's look at our periodic table and just pull that up. So here's our periodic table again. We're going to write on here and just look at some elements and write the shorthand notation just to give you some examples of how to do this. So let's say we're looking at the element magnesium. So if we're looking at magnesium, here's magnesium on the periodic table. So we go ahead and we look at the nearest noble gas. And if you said to yourself, well, the nearest noble gas to magnesium is neon, then you'd be correct. So the first thing we do is we write neon in brackets, because it's the nearest noble gas. And then we write all of the things that lead us up, all the electrons that lead us up to magnesium. So if you look at this, you'll see that the elements that lead us to magnesium are sodium and then magnesium itself. So we have to represent those 2 electrons. So we say they're in the 3. This is the s sublevel. So we have the 3s2. So this is our electron configuration, our shorthand electron configuration for magnesium, neon 3s2. So let's just back up a little bit. let's try another one. Let's say we looked at something a little bit more difficult maybe. Let's say we were looking at the element 10. Okay, so here's 10. The nearest noble gas, the previous noble gas, is krypton. We have to count the number of electrons that will take us all the way to 10. So we have elements in the 5s. So we're going to go ahead and write this out. So here's our shorthand. So we have krypton, Kr, in brackets. Then we have the 5s2. Then we have to represent all of these electrons here in the d sublevel. Okay, and we're, once again, this is the 4d, 10. Then we have to get from, we still are missing the 2 more to get us to 10. We have to write down indium and then 10, which is in the p sublevel, and it's in the 5th row, 5th energy level, so the 5p2. This is how you write shorthand electron configurations. If you have any questions about this, please look back at some of my other videos, and that will help you out. Or there's a lot of other resources you can look at. Look in your textbook to kind of research some information about this, and try them out and see how you do with them. There really is not much to it other than just identifying the nearest previous noble gas and then writing the electron configuration just like you have in the past. And if you have any questions, please feel free to contact me. I'll be more than happy to help you out with that. So thank you for your time. I hope this was informative and gives you what you need. All right, thanks.